Morning, good evening, everyone. Let's go ahead and start. Yesterday, we have started understanding LangChain agents middlewares. This is a concept we started. Let's recap once. Okay, let's recap once and continue next. Let's recap once and continue next. So if you see the documentation, so let's go to the documentation directly. So this is what we started, LangChain agents. If no agent, we understood the architecture. So if no agent, we understood the if no middleware, then we understood the architecture. So if there is no middleware, you can see user, then response, in between agent. So that means you entered the prompt, okay. So we'll go on, then agent runtime. So that's where the model call, all those things happens. Then you get the response. This is what it is. Then in between, we want to intercept something. That means before calling the model, before calling the tool. So here what agent is doing, okay, agent perform, okay. So model calling and tools calling like that, right? Let's say I want to do something before model call. Okay, so after model call, before tool call, okay, after tool call, then what to do? So we can use the concept of middlewares. This is what we discussed. So if you see here, we started with the middlewares. Okay, LangChain agents middlewares. Let's recap once and continue on top of it. So without middlewares, the architecture is user agent response. That's it. Now agent internally, agent runtime, internally do all these things. That's it. Now I want to intercept some logic before model, after model, before tool, after tool. Then what to do? What is the meaning of intercept logic? You can see we are passing lots of data between this layer. Assume that this is the input layer, this is the agent layer, and this is the response layer. So between the layers, we are passing lots of data. Now the question is it worth to pass the data directly or massage before passing? Yes, definitely. It's good to filter the data. It's good to validate the data. It's good to secure the data. It's good to transform the data. How do we do all these things? Using middlewares. How do we do all these things? Using middlewares. That's what we started yesterday. So that's why if you see the architecture with middlewares, this is what it is. So if you see the architecture with middlewares, this is what it is. So you enter the prompt, user prompt, okay, then this is the response. These two will be same. So in between there is a agent, then before agent you can do something, after agent you can do something. So that means before agent what will be there? Request. So before agent you want to validate the request, okay, you want to limit something, you want to add context. Those are all you can do before agent, before execution. Then agent runtime. Agent runtime is the one which start executing the tools, okay, invoke the models, all those things. Then once that is done, okay, you get what? Response, right? Now, so after response, you can do massaging. That means you can print the log, you can cache it, you can validate it like that. Then you give the response. So therefore, before agent execution, I want to do something. After agent execution, I want to do something. Then we can use the middlewares. This is what we understood yesterday. Now you can see agent middleware is a layer. What is the agent middleware? It's like a piece of the code. It's like a layer. Sits between agent and its execution environment. It intercepts and modify the flow. So that's what it intercepts and modify the flow before agent, after agent execution. And this we spend enough amount of time. Then this also we studied. Let's recap quickly this. So the general flow is what? The general flow is, okay, so request will come to the model. Model will identify what are all the tools available. Then tools get executed. If no tools, then it will provide the results and stop the execution. So now we want to introduce the middlewares, right? So therefore request will be as is, results will be as is. In between, you you can do all these magics. Before agent, okay, after agent, you want to do something, yes, you can do it. Then before model, after model, you want to do something, then you can do it. Okay, then we have two more things, wrap tool call, wrap model call. These are around tool, around model. So if you want to do around tool something, then you can use. Okay, so if you want to do something around the tool, you can use wrap tool call. If you want to do something around the model, then you can use wrap model call. Then if you want to understand the restaurant example, in the restaurant, customer will come and place the order. Then who will cook that? Chef will cook that. But in between, there is a supervisor. We call it as a middleware. So what this supervisor will do? Supervisor will check the quality, make sure no mistakes, check the ingredients, check the taste, make sure customers are satisfied like that. That's called middleware. Okay, that's called middleware. So therefore, that's called supervisor. That's called middleware. So those validations done by the supervisor. Then okay, so if any tools, then supervisor can log the information, take the feedback, all those things. Finally, this is served. Like this, we understood the layman terminology also. Then we understood what middleware responsibilities, right? So validate, authentication, okay, guardrails, tool controls, logging, all those things. Then types of middlewares: pre-processing, post-processing, tool middlewares, guardrail middlewares, logging middlewares. Like that we have seen. Then what are the equivalent terminologies? So like so far we studied middlewares, agent, tool, checkpointers, all these things in AI, right? Now let's assume that you are a Java person. Then what are the equivalent terminologies in the Java? So if you take the agent, it's like a service layer. If you take the memory, it's like a session context. If you take the checkpointer, so workflow, state, persistent. Okay, guardrails, validation layers. Like that, you can visualize if you're a Java person or a Spring person, the AI concepts you can correlate like this. This also we have seen. Then this LangChain and deep agents purpose, LangChain and deep agents provides lots of inbuilt, pre-built, okay, pre-built middlewares. So these are the list. So there is a summarization middleware, HITL middleware, okay, model call limit middleware, tool call limit middleware. Like this, we have lots of pre-built middlewares. Like this, we have lots of pre-built middlewares. Then we understood we can also create custom middlewares. We can also create our own middlewares. So to create our own middlewares, we have two methods. Okay, node style hooks and wrap style hooks. Node style hooks means what? So before agent, you want to perform something. After agent, okay, before model, after model, then we can go with this available decorators, which are node style hooks. Then wrap style hooks. You want to do around the model invocation something. Around the model invocation something. Then we can go with the at wrap model call decorator. You want to do around tool invocations. Around the tool invocation, you want to do something. Then you can go with the at wrap tool. Okay, at wrap tool decorator. We'll practice all these things with the examples. Okay, that's it. Then we have done one scenario. Okay, this is what we completed, right? So scenario one. What is the scenario one? You can see this one. Create a login middleware. Apply when agent is created. Create a login middleware. Apply when agent is created. So assume that no middlewares. If no middlewares, what are the steps we have completed? Can you see this one, please? Let's take okay small comparison chart. Okay, so okay, no middleware and if middleware, no middleware and if middleware. So let's see the steps. So what are the steps we followed? If no middlewares and if middlewares, if no middlewares and if middlewares. Okay, so if you go to our code, So you can see this is how we have written the code before, right? So first we load the environment variables. Okay, so load the environment variables. That's what we have done. Then we imported the libraries. Import libraries. That's what we have done. Then we initialize the model. Okay, we initialize the model. This is what we have done before. We initialize the model. After that, we create the agent. We create the agent. For this agent, we mention the model information and prompt information. Model information and the system underscore prompt information. System underscore prompt information. Then finally, we invoke the agent. So this is what we have done. Okay, so create agent and okay, create agent. Then create agent by passing by passing model information and prompt information. Model information and prompt information. Finally, we invoke the agent. Okay, so invoke the agent by passing the user message. By passing the user message. Okay, so by passing the user message. This is a system message. System prompt. This is the user prompt. These are the steps we have done, right? So you can see this program. These are the steps we have done. When you run this, it is working. Okay, just run this, it is working. Okay, now you can see it is working. This is what we have done many times. Now, so what is the requirement? So these are the steps. Now, what is the requirement? Come back to our requirement. Our requirement is, okay, so come back to our requirement. What is our requirement? We want to, okay, we want to introduce login middleware. We want to introduce login middleware. Apply for agent creation. Apply when agent create. So that means what is a middleware? It's a piece of code. It's time to introduce a piece of code which is related to the login. So the requirement is, okay, before model, I want to, so therefore, before model call, we want to display all the information. Then after model call, we want to display all the information. Before model call, what will be there? Request information. After the model call, what will be there? Response information. Request information, response information. How to do that? Okay, how to do that? We coded yesterday this one, right? If you see the steps, steps are same. First, load the environment. Okay, load environment variable, same. Okay, so if we have a middleware, same steps, but little difference, right? So then import the libraries. Yes. Okay, import the libraries. Then initialize the model. That is also required. Okay, initialize the model. That is also required. Now you can see what the requirement. Create a login middleware. Apply for create agent. So we created an agent here. Okay, so we created an agent here. Okay, so now we need to create a login middleware. Apply when agent is created. So then that's what we are doing, right? Now you can see we are trying to create a middleware. This middleware is at a wrap call, at a wrap model call. That means we want to apply around the model. Okay, then you can see the requirement. Before model call, display all the information. After the model call, display all the information. Before the model call, what will be there? Request information. After model call, response information. Request information is available, okay, in the request. So therefore, you can see here, we displayed all the information like this. Then model call. Model call is nothing but handler of the request. This is what actual model call. Then which will verify are there any tools, okay? Then execute those tools, all those things. Then finally kept the response in the RRRS response. Again, after the model call, we displayed all the information. So therefore, here what is the extra activity we are doing? The extra activity is we created the middleware. Okay, we created the middleware. Then while creating agent, you can see create agent. Okay, so while creating agent, what are we trying to do? We pass the model, then we pass the system prompt. Okay, system prompt. Then if there are any tools, pass the tools. Then finally mention the middleware information. Finally mention the middleware information. That's it. Finally mention the middleware information. That's it. These are the extra. This is the extra we are doing. So this is the extra we are doing. That's it. Then you can then next step is same. Invoke the model. Invoke the model with what? User prompt. Invoke the model with what? User prompt. Okay. So this is the system prompt. You can call it as system prompt. System underscore prompt. User underscore prompt. Or human message. Okay. That's it. So this is what we have done, right? This is what we have done, and you can see when you execute it, it is working. So you are trying to invoke the model. So agent.invoke. Agent.invoke is having the middleware. So therefore it will go to the middleware and user information, all these things, the message information, prompt information, all these are available in the request. So we displayed it. Then handler of the request, which will call the model, that internally verify are there any tools. Yes, there is a Tavily search tool that also get executed. That information kept in the tool messages. Then you get the response. Then response is get returned to the invoke method. Then we just display like this. So that's why we have 4 messages. And if you see here, this model, this middleware got executed 2 times. This middleware got executed 2 times. Why it is executed 2 times? Okay. So why executed 2 times? If you see when we print this, right? So we have 4 messages here. This we understood before also. Let's recap once because that is important. Okay, let's recap once, that is important. Now you can see, let's say this is a model. Okay, this is a model. Okay, so this is a model. Now you are trying to say invoke, right? When you say invoke, all the information kept in the human message, all the information kept in the human message, user prompt information, all those things kept in the human message, and request 1 will go to the model. Request 1 will go to the model. This is the request 1. Request 1 will go to the model. Now that means whenever model request 1 will go to the model means middleware got executed. Middleware got executed. So therefore it is going to print all this information. Then model got executed. Okay, there is a model call here, line number 26. What this model call will do, it will identify are there any tools. Yes, right, there is a Tavily search tool. Okay, so those information returned in the AI message. So those information written in the AI message. So that means are there any tool calls, all those things got written here. Now those tools got executed. Okay, so I'll just use shortcut Tavily search. Okay, so Tavily search. That's got executed, and that information kept in this tool message. That information kept in this tool message. Now, are we having any more tools? Are we having any more tools? No, right? So that's why one time got printed. Okay, one time got printed. Then are we having any tools? No tools. If no tools, then whatever information is available, that means a user prompt, this tool information again sent to the model. That means there is one more request. Okay, request 2. There is one more request 2. So therefore, whenever there is a request, okay, here is a request. So therefore, okay, before model call, all these get printed. So that's why second time. In the second time, you can see total messages are 3. That's correct, right? Right now we are here. AI message, first one is human message, AI message, tool message. 3. Okay, then model call happens. Now model will analyze everything, massage everything. Okay, and analyze everything, massage everything. Is there any activity pending? No activity pending. Summarize everything and kept in this AI message. Summarize everything and kept in this AI message. That means a model is completed. Then we displayed this response. Okay, we displayed that response, or we displayed this message. We log this message. Okay, then finally this will return to this invoke method, and we got the response displayed. So like this, we have two requests, two model requests. So that means 2 times middleware got executed. That's why you see this is one time, this is another time. This is what we understood completely in the last session. Now let's continue on top of it. Let's continue on top of it. So the next scenario is, this is the notes for it. Okay, so this is the execution we discussed. The next scenario is scenario 2. Okay, scenario 2. So we want to use the dynamic models. So understand the scenario here. We have static models and dynamic models, but I want to use the dynamic models. So what is the meaning of dynamic model? Okay, what is the meaning of dynamic model? Dynamic model selection. Create dynamic model selection. What is the meaning of dynamic model selection? Using middlewares. What does that mean? See the scenario. This is the scenario. Please understand the scenario. It will be easy for writing the code. Now we don't need to type every time. We can just, we already have the steps here, right? We already have the steps. We will just change it as per the current requirement. That's it. Okay. So now that scenario 2 is dynamic model selection. Dynamic model selection using middlewares. How do I do that? What does that mean, dynamic model selection? If you see the previous example, okay, if you see the previous example, so here there is a user prompt, right? So here there is a user prompt, user message. If the user message is complex, I want to use latest models. If the if the user prompt is simple, then I want to use old models for casting purpose. Because latest models, let's say if I use GPT 5.4, we have different models, right? Let's say there is a so far we are using GPT 4.1 mini we are using. Why we are using 4.1 mini? GPT 4.1 mini we are using because this is a less cost model, and which has less trained information. If you then we can use GPT 5.4. GPT 5.4 is a little more cost model which has high information, So therefore we want to use this if user prompt. Okay, if user prompt is simple, if user prompt is complex. Okay, if user prompt is complex, I want to dynamically select it. Okay, or if the user prompt is having Chenna, if the user prompt is having RRRS. Okay, if the user prompt is having RRRS. When to use this? If a user prompt is simple, then use this so that your cost will be less. If the user prompt is complex, then you want more data, more accurate data. Okay, then in that case, go with the complex model like this. So this is what the requirement. So that's what I kept here. Can you see this one, please? So there is a user, he has the message. Then if the user prompt is simple, okay, if the user prompt is simple, then I want to use GPT 4.1 mini. Okay, then if the user prompt, okay, if the user prompt, human message, has more messages. So you can see right now how many messages are there? 3 messages, 4 messages are there, like that. So if greater than 3 messages, then I want to use GPT 5.4, or I have two conditions. Okay, so the last message, So the last message contains Chenna, contains RRRS, contains complex. Then I want to use GPT 5.4. This is the requirement. So this I want to dynamically decide. This I want to dynamically decide. So now let's see how do we do this. This I want to dynamically decide. Now let's see how do I do this. Okay, so instead of typing, we can copy now because we know it is a fixed steps, right? I just created a new cell. I just created a new cell. Now dynamic model example, dynamic model selection. Okay, dynamic model selection. So it's a fixed examples. Okay, sorry, fixed coding steps. So therefore, I am just taking this dynamic model selection coding. Okay, I will just paste here so that we can save the time. Okay, all right. Now I will just delete this. I'm just massaging as per our steps. Okay, then this one, then this one. So let's remove this, not required. Now let's see what are the steps we have done for before exercises. So what is the first step? Load environment variable. Same thing I have done. Load environment variable. Now before we do this, we need one more step extra here. Okay, before we do this, one more step extra here. What is the one more step extra? If you see the requirement, we want to use GPT 4.1, GPT 5.4, and that selection is dynamic. So that means we need to mention models information in the environment variable. So you can see I just mentioned two models information in the environment variable like this. Okay, so this is what we have done. So model 1 GPT 4.1 mini, model 2 GPT 5.4. Like that I mentioned the models information. So therefore mention model information. So there is a one step extra. So maybe what I will do is that I will just copy this. I will just copy the steps and put it here. I will copy the steps and put it here and try to modify it so that you can see. Okay, try to modify it so that you can see. Okay, I just create a one row above. So what we need to do? We need to put model 1 information, model 2 information, model 2 information in the .env file. That's what we have done. Remaining is same here. That's what we have done. Then load environment variables. Load environment variables. That is okay. The next one is import the libraries. You can see I imported the libraries. Then initialize the models. You can see initialize the models. Now you have two models, right? Model 1, model 2. So initialize the model 1, initialize the model 2. Initialize the model 1, initialize the model 2. We have two models. So you can say M1 model 1 and M2 model 2. Then earlier what we did in the before exercise, we need to create a middleware, right? We need to create a middleware which select the model dynamically. Okay, so we need to create a middleware which select the model dynamically. So this is the extra we are doing. Now we need to create a middleware which select the model dynamically. So let's see how do we do this. It's a very simple. So I just written the method called RRRS dynamic model selection. It's a method name. So this is the method name we have. Okay, RRRS dynamic model selection. Okay, now you write the logic. So it will take the request, it will take the handler. Request is model request, and finally it will return the response, model response, right? Response, model response. We are just writing more specific formatted way. Request, model request, handler. Okay, then response. Response is model response. Like this, we are defining a function, and this is around the model. This is around the model. That's why we are using that decorator. Around model decorator. That means whenever model get executed, this will be. Now you can see So what is the logic we need to write? The logic is nothing but, so we need to check, okay, if the prompt is simple. If prompt is simple, GPT 4.1. If the prompt is complex, RRRS or Chenna. If the prompt is having this kind of words, then GPT 5.4. Or if the prompt is having too many messages, if the prompt is having too many messages, then GPT 5.4. Now let's see. Okay, first we need to count these messages. First, we need to count the messages. See the logic, please. So how do I count? Message count, that is a variable, length of request dot messages, means request dot state of messages. So request will hold all the messages information. Okay, and just display it. This is just displaying. So this will give message count. So let's say in this case, so how many are there? 1, 2, 3, 4. 4 are there. At that moment, whatever count, that count will given. Okay, like this we counted the messages. Okay, then what I need to do next? What is the logic? So I need to check if the latest message or last message contains Chenna word, RRRS word, complex word, then GPT 5.4. So how do I check that? So you can see last message. How do I get the last message? Request dot state of messages -1. So in that content, which will give the last message. So in this case, what is the last message? This is the last message. At that moment, what is the last message? At that moment, what is the latest message? That is the one it will give. Okay, that is the one it will give. Then in that I want to check, is there a Chenna, is there a RRRS, is there a complex? If yes, GPT 5.4. Okay, now you need to write the logic. So I am checking if the messages count greater than 3 or we define these keywords, right? Okay, we define the keywords and we also have the last message. If these keywords are there in this last message, then GPT 5.4. So that's why keywords in messages, I'm just converting it to lowercase everything. The reason is sometimes people can enter Chenna with camel cases, Chenna with lower cases, Chenna with our upper cases. Okay, my keywords are in small case. That's why I just convert it into lowercase. And checking these keywords exist in this okay, lower message. Okay, these complex keywords exist in this message. If yes, you can see I am dynamically assigning this complex model. So that means GPT 5.4. Okay, so you are using GPT 5.4. Else, if this is not, it's a simple prompt, then GPT 4.1 basic model. GPT 4.1, like this we write it. Other than that, nothing here. Other than this, nothing. So remaining steps are same. So this is the extra logic we have written. Remaining steps are same. Now my middleware is ready. Once middleware is ready, what we need to do? We need to plug the middleware with the agent. You can see we are plugging this middleware with the agent creation. So during agent creation, we plugged it. So therefore, in the create agent, okay, so now you need to do the create agent with the model information, system prompt information, tool call information, and the middleware information. So therefore, model information, tool call information, system information, and the middleware information. That's it. So same step. Only this is the difference. The logic is the difference. Then finally, you need to invoke it. So invoke with the user prompt. See this here, steps are same. Invoke with the user prompt. Now invoke with the user prompt. So right now, let's say, now let's test it. This is how we need to write the code. So first, load the environment variables, load the, import the necessary libraries, initialize the models. In this case, we have two models. Now we need to write the middleware to decide which model to use. How do I decide which model to use? Based on the prompt information. If the prompt is simple, GPT 5.4. If the prompt is having more messages, GPT 5. Sorry, if the prompt is simple, GPT 4.1. If the prompt is complex, or if the prompt is having too many messages, GPT 5.4. Or if the prompt is having a keywords like a Chenna, RRRS, complex and all, GPT 5.4. That's why we have written the logic. Now attach this middleware to the agent creation. So therefore, when agent is creating, so we pass the model information. Okay, then system prompt, tools, and whatever middleware we created. Then finally invoke the model. Invoke the model with what? With the user prompt, user message, human message. Okay, that's it. Now let's do the testing. Let's do the testing. So the first scenario, simple. Let's say I will say this as explain Python in 2 lines. Explain Python in 2 lines. Testing 1. Okay, so testing 1, explain Python in 2 lines. So if I do like this, so explain Python in 2 lines means simple, right? So therefore it should use GPT 4.1. So execute it. You can see GPT 4.1 is using, and you got the response. Okay, you got the response. Now testing 2. Testing 2. Testing 2. If you observe the testing 2, so if there is a word called complex, then it's GPT 5.4. Okay, complex. So let's say I will just use complex is a word. Then it should use GPT 5.4. Okay, so this is the testing 2. Okay, now execute it. So you can see GPT 5.4. So that means a costly model is used. Now testing 3. What is the testing 3? Can you see this one, please? Okay, testing 3. So let's say tell about Chenna Reddy RRRS in 2 lines. So that means if there is a word called Chenna, if there is a word called RRRS, what is the requirement? If there is a word called Chenna, if there is a word called RRRS, again GPT 5.4. Okay, GPT 5.4. Execute it and see. So you can see GPT 5.4. Like this, we are dynamically selecting the model. Next, testing 4. Okay, what is the testing for? If messages are greater than 3. If the messages are greater than 3. Okay, message count is greater than 3. Again, GPT 5.4. So for that, what we can do is that, okay, for that, what we can do is that we can say perform, okay, perform math operation like a 2 into 4 plus 8 minus 3 minus 3, then tell about ChennaReddyTraining in 1 line. So like that, I just created this prompt. Now execute it. Now you can see it's going to the 5.4. Okay, because it's having Chenna. Okay, so like this, it will dynamically decide. So therefore, like this, we are dynamically deciding. Like this, dynamically deciding what model to use. So that's it. That's it about this exercise. Like this, we decided dynamically decide what model to use. That's it about this exercise. Okay, that's the scenario 1. So sorry, scenario 2. Scenario 1 is logging middleware. Scenario 2 is dynamic model selection middleware. Dynamic model selection middleware. That's it. Dynamic model selection middleware. So now let's see the notes for this. This is the notes we created. Dynamic model selection middleware. This is the requirement. This is the code, and these are the components used in this. Load environment, chat OpenAI, model request, model response. These are all the different components used for our implementation. At wrap model call, handler, request.model, create agent, agent runtime, agent.invoke. Then what it will do? So this is just for recapping that code in its simplest words. Then this is the execution flow. If you want to see the execution flow, you can see the execution flow. I will just paste this in the paint. Let's look at the execution flow, please. If you come to our program, this is a program written. So therefore, there is a invoke method. Okay, invoke. So whenever you say invoke, then obviously the invoke internally verify create agent. Create agent is having the middleware. So therefore, it will go to the middleware. Okay, so it will go to the middleware. And one more thing is that invoke is using a request, right? Whenever there is an invoke, request object is created, which is holding all the information. What information it will hold? Model request. Okay, model information, state information, tools information, config information, and all. So therefore, that will hold. Then model. Okay, so then it will go to the model. Sorry, middleware. It will go to the middleware, whatever we created. In the middleware, what do we have? Counting the messages, checking the complex words, then writing the if condition to choose the model. Okay, so therefore, middleware. In the middleware, counting the messages, all these things. Then we are writing a if condition. If greater than 3, then costly model. Okay, if the less than 3, then less cost model. GPT 4.1, GPT 5.4. Whatever may be the situation, more messages, less messages, complex message, simple message, whatever may be the message, finally we will do the handler call, model call. So model call. That model call internally, model call means it will call the, or it will, there is a request to go to the model. That model will identify are there any tools, then execute the tools. Then once the tool execution is completed, then summarize the messages, return the results. That results is available in this. So that is what we are returning. Okay, that is what we are returning to the model. So not model, middleware right now. Okay, middleware. So now from the middleware, it will come back to invoke method. From middleware, we can come back to invoke method. So from the invoke method, we are taking and displaying. We are taking and displaying. That's the flow for this. That's it. That's it. That's it. Now let's continue the next one. So the third scenario is error handling. Third scenario is error handling. Third scenario is error handling. First, understand the scenario yourself. Coding is almost same, only depends upon the scenario, we will change it. Depends upon the scenario, we'll change it. Third scenario is tool error handling. So that means, what does that mean? And you can see in the first example, scenario 1, scenario 2. Okay, if you see scenario 1, scenario 2, okay, we used what? At wrap underscore model underscore call. This is what we have used. Now in the scenario 3, we want to use at wrap tool call. At wrap tool call. This is what we want to use. Let's see how do we use it. For that, we are taking a scenario of tool error handling. Tool error handling. That's what we want to use it. Tool error handling. That's what we want to use it. Tool error handling. That's what we want to use it. What is the meaning of tool error handling? Now, if you see the current execution, so if you see current execution, so this is how we have the agent creation, right? The scenario two agent execution is like this. So here we are using the tools. So that means the agent internally calls the tool. So that means, so agent internally execute the tools. So this is a scenario. When an agent calls the tools, so this is the tool, Tavily search tool. What is the Tavily search tool? We discussed it enough before. Okay, so when agent calls tools means what? APIs, functions, okay, database calls like that. then there is a possibility that it can fail. When the agent calls the tools, that means right now we are calling Tavily search, it can fail. Why it will fail? There are a number of reasons. API timeout, okay, API timeout, or invalid input, okay, or like this we have division by 0. Like this we have n number of reasons why API can fail. DB connection error. Like this we have n number of reasons why, okay, why API can fail, tool can fail. Okay, can you see the third scenario, please? Third scenario is tool error handling. Tool means function. Then who will call this function? Who will call these tools? Agent. So therefore, when agent calls the tools, APIs, it can fail. Why it can fail? API timeout errors, okay, invalid input errors, division errors, DB errors, like that. There are n number of reasons why tool can fail, API can fail. Now the question is, if these kind of errors, if these kind of errors, then is it worth to handle or leave the system with a hanging? Okay, if these kind of errors, is it worth to handle or leave it? Definitely yes, we need to handle it. Yes, we need to handle it. How to handle? Using middlewares. Okay, how to handle? Again, using middlewares. So if you handle these errors, then what is the advantage? Okay, why to handle? Why to handle these errors? If you handle the errors, what are the advantages? The advantage is, okay, system does not crash. Okay, then the second one is agent can recover and continue. Agent can recover and continue. Like this, we have many advantages. If you are not handling the errors, your system can crash. Your agent will not continue. Your agent, okay, can, okay, crashes, and so on, so on. So that's why it's time to handle these errors. It's time to handle these errors. How? How? The answer is using middlewares. Using middlewares. So right now I want to use this because we are trying to handle the tool calls, right? Earlier we are trying to handle the models in models. Before model I want to do something. After models I want to do something. That's why we have used a trap tool call. Right now I want to do something related tools. That's why we can use at. That's why we can use at wrap tool call. This is the one we can use it. Okay, at wrap tool call. This is the one you can use it. Now let's see the steps what we have done before. Okay, let's see. These are the steps we have done before. I am just copying. We'll use almost same steps but little difference. All right, we'll use almost all the steps but little different. So instead of writing the code, I'll copy the code so that we can save the time. Otherwise, it will take lots of time to type it. So you can see tool error handling. So same steps, only logic is different. Okay, same steps, only logic is different. Okay, I'm just creating a new cell and pasting that. Now let's see what we did before. We load the environment variables. You can see load the environment variables. Same. Then import the libraries. You can see import the libraries. Then initialize the model. Initialize the model. Those steps are same. Initialize the model. Initialize the model. Those steps are same here. Then what we did, we have written the logging middleware earlier. Dynamic selection, dynamic model selection middleware earlier. Now you need to write your tool error handling middleware. This is where the change. tool error handling middleware, that's where the change. That's what we are trying to write. You can see here. So we want to do a web search. For web search, we are using Tavily Search API. Then you can see RRRS tool error handler middleware. Okay, RRRS handle tool errors. That's what we are writing. That's what we are writing. So that means whenever there is a call to the tool, whenever there is a call to the tool, whenever there is a call to the tool, if any errors, then we need to handle it. Okay, if any error, we need to handle it. Whenever there is a call to tool, means what? Who will call the tools? Agent. Who will call the tools? Agent. When agent will call? Once model invocation is done. What is the logic for model invocation? Line number 36. Handler of the request. We discussed this. Handler of the request will invoke the model. Now model will check are there any tools. If yes, it will go and execute the tools. It will go and execute the tools. If no challenges, then okay. If no challenges, then it will continue the execution. If challenges, it will come to the exception. If challenges, it will come to the exception. And there we will handle it properly. There we will handle it properly. That's it. This is how we created the middleware. This is how we created the middleware, and this is at wrap tool call. That means it's around the tool. So that means whenever tool is invocated, whenever tool is invoked, then this is called. That's what the meaning. Okay, now let's come here. Okay, the remaining steps are same. So then you are creating agent, map your tool. Okay, map your middleware to the create agent. So therefore, create agent with a model, with the tools, system prompt, and you can see middleware. You can see middleware. That's it. Only this middleware logic is same. Remaining steps are, sorry, only this middleware logic is different. Steps are same. Okay, steps are same. Now map this middleware to create agent. Then next step is invoke it. Okay, next invoke it with a user prompt. Invoke it with a user prompt. Okay, now let's test it. Okay, let's test it. Testing one. Okay, agent calls API. Right now we are using Tavily Search API. Assume that all good. All good. So all good means what? So you can see tell about ChennaRRRS training in one line. I just executed all good. All good means you will get the response. All good means you will get the response. You can see we get the response. So what is happening? We are trying to invoke the model. When we try to invoke the model, there is a middleware. So therefore, middleware is called. So in the middleware, you can see line number 36. This is where model is get invoked. Okay, so model. So this is where model get invoked. Now model internally checks are there any tools? Yes, there are tools. So this tool got executed. That means it will explain about ChennaRRRS, right? Explain about ChennaRRRS will be searched over the web. So we discussed this. Let's say, so go to the google.com, ChennaReddyTraining, ChennaReddyTraining. So if you type ChennaReddyTraining, something is coming. So that means that this is where we are searching. This is where we are searching, and search is good. That means no errors. If no errors, then the response is stored in this. That is what we displayed, line number 37. You can see that is what we displayed. And okay, that is what it is displayed. Okay, so you can see currently no problems. Okay, it is doing the web search like that. Okay, so now come here. So then this is the one. Then we are returning that response. We are returning the response mean that is stored in the RRRS response, and from RRRS response you are trying to display the last message. Last message is this one, and finally you displayed all the messages information. Finally, we displayed all the messages information. In a simple word, this is how the logic. Let me take this into the paint. I will just go here, put this. Okay, so let me take some more code. Okay, all right. Okay, I'm just putting the flow here. You can see. All right, let's say there is a model here. This is the model. Okay, this is the model. Now, okay, if you come down, so you can see we try to invoke the model with this message, user message. We try to invoke the model with this user message. Okay, we try to invoke the model with that user message. All right, we try to invoke the model with that user message. Sorry. Okay, so with that user message. So whenever we try to invoke the model with that user message, it will identify what the system prompt. Are there any tools? Are there any models? Are there any middlewares? Yes, middlewares are there. So then it will, okay, so then middlewares are there. Okay, all right, it will come to the middlewares. So now you can see here line number 36. Line number 36. Okay, handler of the request. Handler of the request means what? That's where request will go to the model. Now model will identify are there any tool calls. Okay, let's say this is the first one. Are there any tool calls? Yes, there is a travel search tool call. Then it will go and execute the tools. Now, are there any challenges with the tool execution? No challenges. If no challenges, response is returned. If no challenges, response is returned. Response is returned to your invoke method. So there we have RRRS response that contains our full response. Then from that last message is displayed. Then we displayed all the messages. Like that it is done. Now assume that there is a problem with the API. Okay, assume that there is a problem with the API. So travel search API, assume that there is an invalid key. Okay, invalid key. So let's say I go here, go to the environment variables. There is a travel search. I'm just adding a invalid key. I just modified this as 1122. 1122. That means the key is invalid. So that means search should fail. Okay, search should fail. Let's run this and see. Okay, search is not failed. Why? The key got cached. Search is not failed. Why? The key is cached. So therefore, what we can do is that we can close this editor, open it again. We can close the editor, open it again. I just close the editor and open it again. Now run this. There is a invalid key right now, you can see. So therefore, when you run, it should fail. Okay, when you run, it should fail. Now it's trying to run. Now you can see it's getting running. Okay, so now you can see unable to access the search API. That means tool call failed. Tool call failed. Then what happens? Can you see the code again? So therefore, it will come to this and do a model call. It will come to this and do a model call. That model decides are there any tools? Yes, it will go to the tools. Then it will try to execute the tools. When it try to execute the tools, then we have an invalid key to execute the tools. That's why it is failing. So that means there is a problem here. There is a problem here. Whenever there is a problem, it will jump to the exception. Whenever there is a problem, it jump to the exception. Whenever there is a problem, it will jump to the exception. Now you can see we handled in the exception. So we are checking, is that API error, authentication error, 401 error? Yes, obviously authentication error right now. Okay, so right now it's a authentication error. If authentication error, okay, if authentication error, you can see I am putting this message. Can you please observe here? Can you please observe here? I am handling and putting this message in the tool calls. Like this, we handled clearly. We handled clearly so that system will not crash and continue the execution. That's why you can see all the messages clearly. You can see all the messages clearly. Now, if you observe the tool message, if you see here, we kept in the tool message, right? So therefore, if you observe the tool message, that will have exactly what we kept. Okay. So if you see the tool message, that will have exactly what we kept. So you can see what we kept. Can you observe here? What we kept in the tool message? ChennaRRRS error, web search not working. Please try later. You can see, okay, ChennaRRRS website is not working. Please try later. That is what exactly we try to handle. So therefore here exception error is handled clearly. So agent will continue. Agent execution will continue. System is not crashed. All the messages displayed properly. Okay, all the messages displayed properly. It's not hanging. It's not crashed like that. So let's say that middleware is not there. Okay, let's say this middleware is not there. If the middleware is not there, then it should crash, right? Execute it. So now you can see it is crashing. Okay, if the middleware is not there, then it will crash. Okay, so that's it. That's it. That is about the middleware. So therefore, in the current scenario, what are we trying to do? So scenario number 3, tool error handling middleware. So that means whenever there is a tool call, it can fail. Why it can fail? Invalid key. Okay, invalid API key, invalid input, timeout, all these things. Is it worth to handle them? Yes. If you are not handling, then your system can crash. Agent cannot continue like that. So therefore, if you handle, system does not crash, API can recover and continue as normal. For that, this is how we will do the coding. For that, this is how we will do the coding. That's it. Now let's go to the environment and change this to back for future purpose. Otherwise, future whenever we are using, it may fail again. That's about tool call, how to handle the tool errors. How to handle the tool errors. That's about the scenario 3. Okay, just give me a second.
This conference will now be recorded.
Okay, sorry, let's continue. So that is how we completed this. Now let's see the notes for this. So we discussed a tool error handling mechanism using middlewares. For that we have used at wrap tool call. Okay, for that we discussed what are the different possibilities. Tool can fail, API can fail. If you are not handling, then system can crash, agent cannot recover. So how to do it? This is what the code, and these are the some of the points which are useful to recollect that code, whatever we discussed. Okay. Next scenario. So far what we have done, scenario 1 is what? You can see, let's recap once. Scenario 1, create logging middleware, and we have done. Then scenario 2 is dynamic model. Scenario 2 is dynamic model. That's the scenario 2. Then scenario 3 is what? Tool error handling. Okay, scenario 3 is tool error handling. Next, scenario 4 is if you see the previous code, let's come back to this code. So there is a system prompt here, right? There is a system prompt here. This I want to make it as a dynamic system prompt. There is a system prompt here. Okay, system prompt. Make the system prompt as dynamic. So therefore, scenario 4 is okay, create system prompt dynamic. Okay, dynamic. So for that we can use at dynamic underscore prompt. This is the decorator, we can use it. Okay, so this is the decorator, we can use it. So I'll just change the color of this. So first two uses at a wrap model call. Third one uses at a wrap tool call. Now dynamic prompt. So you got the requirement, right? So right now this system prompt is static. I want to dynamically create this. Let's see the requirement. Requirement is, so we have user input, right? Based on the user input, based on the user prompt, based on the human message, I want to generate the system prompt dynamically. So therefore, requirement is based on the user prompt. Okay, based on user prompt. So user prompt is nothing but human message, right? Based on the user prompt, we want to create system prompt dynamically. For that, you can see the scenario. I'm just showing the flow. Okay, so this is the flow we want it. So let me take this into the paint. Okay, let me take this into the paint. Please understand the scenario here. Coding is steps are same. So this is what we want. We want to have some basic prompt. That's nothing but you are a helpful assistant. Then if the user prompt is a student and a beginner, then if the user prompt is student and a beginner, can you see this one how I will change dynamically? Then I want to use this and give answer is one line. Okay, answer should be only one line. Okay, so if the user prompt, that means user role is student, but level is advanced. If the level is advanced, then I want to give the answer in 2 lines. So that means I want to append dynamically. Then, then user role is a student. Sorry, teacher. User role is teacher. Then I want to give 3 lines response. Okay, I want to give 3 lines response. Okay, if the user role is professor. Okay, if the user role is professor, then I want to give 4 lines answer. Like this, we want to generate system prompt dynamically and give the results accordingly. Can you see this one, please? If the user role is student and he is a beginner, expert level beginner, I want to give answer in one line. User role is student, but he is an advanced guy. Expertise level is advanced. I want to give the answer in two lines. If the user role is teacher, I want to give in 3 lines. If the user role is professor, I want to give in 4 lines. Nothing. Again, just give whatever it is. Like this, we want to generate the system prompt dynamically. These are the rules we want to follow. System prompt dynamically generation rules are this. System prompt dynamically generation rules are like this. Got it? So if you get it, then let's write the code. Again, steps are same, only, okay, steps are same, only the middleware get changed. Steps are same, only middleware get changed. So that's why I just copied it. Okay. Now let's go to the code. If I type the code, it will take lots of time. We'll try to reuse the code and explain. Okay. So I'm just copying this code. I'm just copying this code and go to the editor, create a new cell and paste it. Create a new cell and paste it. Okay. Then okay. So create agent and invoke the agent. Okay, that's fine. Create agent and invoke the agent. Okay, I'm just rearranging here and there so that you can see clearly. Okay, all right. Now let's see the steps. So the first one is what? What did we do before? Load the environment variables. So you can see here also we have done the same. Okay, load the environment variable. Okay, you can see here. Actually, here we hard coded it. We should not hard code. That's okay. Okay, that's it. Then import the libraries. You can see we imported the libraries whatever needed. Then initialize the model. You can see we initialized the model here. Okay, here directly, which is okay. Instead of doing outside, we just did inside. That's okay. Then for the current scenario, what we need to do? We need to create system dynamic. Okay, system prompt dynamically. So therefore, we need to write a middleware. We need to write the middleware. So you can see we are trying to write the middleware called the RRRS adaptive system prompt or dynamic system prompt. You can say dynamic. Okay, dynamic system prompt. That is the one which you need to pass to the agent creation. So that is the one you need to pass to the agent creation. So therefore, create the middleware. Come here, create the middleware. So RRRS dynamic system prompt. Then to create a dynamic system prompt, what are the rules? These are the rules, right? Okay, these are the rules. So therefore, we need to check user role is student and his expertise level beginner. You can see. I said you need to use this decorator. You need to use the decorator. Then web search, that is for the web search purpose. Then we are trying to map user role and expertise level into a context class. So that we, in a simple word, user role, here we have two things, right? User role, expertise level. Let's group into one class. That's it. Okay, now come back here. We need to check user role is student, his expertise level is beginner. Then give the answer in one line. Okay, so that's why you can see this is the one, then model request. Okay, then generate the system prompt dynamically. That's the requirement. Now you can see context. We are trying to get the context. So request.runtime.context has runtime context, else we'll generate it. So we need to generate it, right? So you can see user role. Okay, so user role general or expertise level beginner. Okay, user role expertise level we are getting it. User role expertise level we are getting it from the context. What is the context? So you can see we are providing here context. So during invocation, we are providing the context. So from the context, you can see there is a user role, there is a expertise level. From the context, you can see there is a user role, there is a expertise level. Get this information. Okay, get that information, user role and expertise level information. Now check if the user role is student, expertise level is beginner, base prompt. What is the base prompt? You can see you are a helpful assistant and I am appending give answer in one line. Okay, so user role is student. That means you are saying student, but else means advanced. Then give the answer in two lines. Give the answer in two lines. Now user role is a teacher. Okay, user role is a teacher. Then give the answer in three lines. User role is professor. You are passing professor. Then give the answer in four lines. Like this, you create the dynamic system prompt middleware. This is the code change. Other than that, nothing. It is just a if condition to identify what is the user role and expertise level. What is the user role and expertise level. Remaining are same here. Remaining are same. Then this middleware you need to put to the create agent. You need to map to the create agent. So you can see create agent. So pass the model, pass the tool, pass the middleware, and so we have a class here, right? So that also you mention it. So that means the agent should aware whatever we created. Agent should aware whatever we created. Now here system prompt is not required because we are generating dynamically in the middleware. We are generating dynamically in the middleware. So that's why during agent creation, system prompt is not required. System prompt is not required. So we just mentioned the model information, tools information, middleware information, and the context information. So the context is okay. Context is okay. Context schema information. Context schema. What is the context schema? That's what we are passing here. Role and expertise level. That's it. That's it. That is what we have done. Now we are trying to invoke it. Invoke it with a user message and invoke it with user message and context. So earlier we did only with the user messages, user prompt. Now you need to pass the context also, whether that guy is a student or professor or teacher like that. Now let's do the testing. Okay, let's do the testing. You can see explain about AI. This is the user message. Explain about AI, testing one. So explain about AI, this is the user message. Okay, explain about AI, that is the user message, user prompt. But the context right now is, student and beginner. Okay, context right now is student and beginner. If a student and beginner, what should be system prompt? Give the answer in one line. Now let's see. I just executed it. Now you can see we are getting in one line. You can see the size. This is what we got it. Then testing 2. Okay, let's do the testing 2. What is the testing 2? Instead of beginner, okay, else, let's say advanced. Okay, so student else means give the answer in 2 lines, right? Else means give the answer in 2 lines. So therefore, context I am saying like this. Okay, context I am saying like this. So student advanced. Now we should get the answer in 2 lines. Okay, so the system prompt is you are a helpful assistant, give the answer in 2 lines. Now let's see whether we are getting in 2 lines. So I'll just copy this and paste here. You can see here less information, here more information. So therefore output is increased. Next, testing 3. Testing 3 is what? Okay, let's say he is not a student, he is a professor. Okay, he is a professor. Then answer should be in 4 lines. Or let's take teacher first. Okay, teacher. Then answer should be in the 3 lines. Okay, so if you see here, okay, let me make this as bigger. Okay, now you can see answer, it is a little bit bigger than this, 3 lines. Okay, next let's make it as professor. Professor means 4 lines. Okay, professor means 4 lines. Now you can see it should be a big one. So go to the testing 4. You can see this is a bigger one than this. Like this, based on the like this, system prompt got generated dynamically and used it. Let's say he is not a student, he is not a teacher, he is not a professor. Then what? Let's say he is a triple RS, something, no related. Then the system prompt is you are just a helpful assistant. That's it. You are helpful assistant. That's it. You are helpful assistant. That's it. Now let's execute it. You will get some randomness, not one line, 2 line like that. Not one line, 2 line like that. Okay, you can see something else you got it. That's about this dynamic system prompt generation. Dynamic system prompt generation. That's it. Dynamic system prompt generation. That's it. Now let's go on to see the nodes. Okay. So dynamic system prompt generation. For that we are using at dynamic prompt. So then what is the system dynamic prompt or system prompt? System prompt defines the AI behavior. Anyway, we know what is the meaning of system prompt versus user prompt. So this is the coding. Okay, so this is the coding and this is the execution flow. Let's see the execution flow for it. Let's see the execution flow for it. Now look at this one, please. First, okay, so we have something called a web search. That's a function. Okay, we have something called web search. That is a function. Then there is a model information. There is a schema information. That context. So these are all what we have. Okay. Then there is a create agent, right? You can see create agent with all this information. Create agent with all the information. Then there is a okay. So dynamic prompt that attached to this. How it is attached to this? Because there is a invoke. Okay. So during the invoke, you are passing messages and the context. messages and context. Then model got invoked. Sorry, middleware got invoked. Okay, so this is the middleware. Then it will try to do all the magic. It will try to do all the magic. Okay, so once that is done, it will do all the magic. Then model call. There is a call to the model. Okay, there is a call to the model, which will take all this information, go and talk to the models, and that requires the tools, execute the tools. Okay, that requires the tools, execute the tools. In between, it will use that system generated advanced prompt, dynamic prompt. Okay, and do all these things. Finally, return the results. So you can see during the model call only that a system dynamic system prompt is used. Okay, but that results is attached to this create agent. Okay, so therefore this is how the pipeline or this is how the execution flow. So therefore, what are all the different pieces we have written here? What are all the different pieces we have written here? So there is a context, there is a model, there is a search, there is a dynamic prompt logic. Then create agent, invoke agent. When you invoke the agent, model get called. That model uses the dynamic prompt. Then dynamic system prompt that got generated. Then model get executed. Then finally, if any tools are required, tools get called. Then everything is completed. You will get the response. That response you are displaying here. That response you are displaying here. That's it. This is the flow. This is the execution flow. So this is also there in the notes. Okay, this is also there in the notes. Okay, that's about this one. These are the 4 scenarios. So if you go to here, so first scenario is logging middleware, dynamic models middleware, error handling middleware, or tool error handling middleware, dynamic system prompt middleware. All these are done, all these are executed. So the next requirement is, or the next scenario is, okay, next scenario is scenario number 5. So if you see here, okay, if you see here, we are able to see the human messages, we are able to see the tool messages, we are able to see the AI messages, but we are not able to see the system messages. In scenario 4, okay, in scenario 4, system messages are generated dynamically, right? Dynamically, but we did not see. We are not able to see. Okay, we are not able to see. If you see the scenario 4, system prompt generated dynamically, we are not able to see, right? Okay, we are not able to see. This is a problem. This is a challenge right now. Then how to see? How to see the system messages or system prompt? So therefore, scenario 5 is we can see human messages. We can see AI messages. So you can see here human messages, AI messages, tool messages. All these things we are able to see. But we can't see system messages here. System messages here. If you see in the 4th scenario, we generated the system prompt dynamically. What is the proof that it is generated? With 2 lines, 3 lines, 4 lines. For that, it's time to see. Okay. So therefore, how can we see the system prompt or system messages? How can we see the system prompt or system messages? Okay, how can we see? Right now we are not able to see, right? For that the answer is we can use LangSmith. Okay, LangSmith. This is another application. For that the answer is we can use LangSmith. Now what is the LangSmith? So if anyone asks what is LS, LangSmith? So it is an observability tool. Okay, observability and evaluation platform for debugging purpose, debugging and monitoring, debugging and monitoring LLM applications. That's it. So LLM applications, models applications. So if anyone asks a question, what is a LangSmith? What is a LangSmith? If anyone asks a question, what is a LangSmith? What you need to tell? It's a observability platform. It is a evolution platform. It's a platform for debugging and monitoring. It's a platform for debugging and monitoring. So that means all the information you can see here. Now, if anyone asks how LangChain application can be debugged, we can use LangSmith. How LangChain application can be monitored, we can use LangSmith. How we can see the system prompts, we can see system messages, we can use LangSmith. Question is same, answer is same, LangSmith. How to see the system messages, LangSmith. How to observe the what is happening in LangChain agent applications, LangSmith. How to monitor LangChain agent application, LangSmith. How to debug LangChain agent application, LangSmith. Whatever may be the question, answer is same. So therefore, LangChain is a solution for all these things. In a simple word, LangChain, okay, LangChain plus agent plus LangSmith, okay, LangSmith is equal to, if you are a Java person, there is a logging framework, right? Logging framework. Let's say log4j plus monitoring. Monitoring purpose, we can use Splunk like that, right? Splunk like that. So that's the LangSmith. So LangChain plus agent plus LangSmith equal to, if you are a Java person, you can visualize it's like a log4j and monitoring. You can visualize log4j and monitoring. So log4j and monitoring if you are a Java person. That's it. That's about the LangSmith. If anyone asks LangSmith, if you are a Java person, you can visualize log4j and monitoring tool like a Splunk like that. Okay, all right. Now let's see how do we do this. Okay, how to enable the LangSmith and debug it. So our next question is how to enable LangSmith and debug or monitor the LangChain agent application. LangChain agent application. This is what our next question. Okay. So therefore, to use, obviously, to use the LangSmith, we need API key. To use LangSmith, we need the API key. Okay. And also, we need to install pip LangSmith. So go here. Okay. Create a new cell. So install the pip. Okay. Pip install LangSmith. So this you can install it. If it is already there, you are good. If not there, you need to install it. Install that package. Okay. Then to use LangSmith, we need API key. Take the API key, put in .env. So that's the step number 1. How do I get the API key? So you can go to the smith.langchain.com, smith.langchain.com. You can go here, and if you have an account, you can sign up. Else, okay, you can sign up and log in. You can sign up and log in. Then there is a settings here, settings, and create a new API key. Create a new API key with default package information. Okay, and you can give the description. Let's say ChennaRRRS LangSmith, and create a key. So I already created the key. This is the one. So therefore, take the key and put in the environment variable. Okay, so these are the things you need to put it. These are the things you need to put it. 4 parameters you need to put here. These are the 4 parameters you need to put. That's it. These are the 4 parameters you need to put it. Once you put it, then it's a very simple, straightforward. Now, okay, your LangChain, your LangChain agent application, okay, LangChain agent application is connected with the LangSmith. It's connected already. Okay, step 2 is testing. That's it. No big differences. Step 2 is testing. That's it. How do I test it? You can go and run your any existing application. Okay, testing. So run any existing application. Run before applications and monitor it. Okay, just you need to put the get the key and put in the environment variables so that your LangChain connected with the LangSmith. Now let's run this itself where we have system prompt and all. Okay, so let's say here I will put a teacher. So teacher means 3 lines, right? Teacher means 3 lines. So execute it. Okay, execute it. Now let the results comes. What happened? So execute it. Yeah, results is coming, right? Yeah. Now go to the LangSmith. Go to the LangSmith and go to these applications. Go back. Applications, all applications. Now this is the one which we created. So open this. Open this, and yeah, you can see here. Just now, what is the time? Okay, you can see this is the UTC time. Okay, let's go to this only. So let's open this. If you open this, now you can see explain Python in 2 lines. Okay, so one thing is we just enable this, right? But it's not applied. So therefore, close the editor, open it again. Close the editor and open it again. Close the editor and open it again, because those keys are not applied because it's kind of a caching. Okay, now let's do one thing. I will run this. Okay, now I'll run this. Any existing application, we can run it. What happened? OS is not defined. Okay, so there is a import missing. Let's do a import once. Okay, let's do a import once. Now run this. Okay, agent create. Some imports are missing. Create agent is missing. So let's do a create agent. Now run this. We are good. Now we got the answer. So with the teacher, we got the answer. Now let me run with the professor also. Let me run with the professor also. So we ran 2 times. One with the teacher, one with the professor. Now go to the LangSmith. Let's refresh once. Okay. And go to the applications. Go to the application. This is the one which we created. Open this. Now you can see entries are there. So therefore, when teacher, then your system prompt should be, you are a helpful assistant, give 3 lines. When professor, your system prompt should be, you are a helpful assistant, give answer in 4 lines. That is how it should be. But we are not able to see the system prompts in the LangChain application. So in the LangSmith, we can see. So therefore, go ahead and see this one. Open this. If you open this, okay, if you open this user prompt, you can see. Okay, just search with your SYSTEM. Otherwise, go to this model. Okay, you can see. Okay, you are expertise in web search. And what is the question we asked? Explain AI. Okay, these are the old ones, right? Let me go to the latest one. Okay, yeah, this is the latest one. So you need to go for top. Top is the latest one. So that means latest one is professor. Professor means give, you are a helpful assistant, give answer in 4 lines. So therefore, you can go here and click on the model. Now you can see you are a helpful assistant, give the answer in 4 lines. That is the system prompt, system message. And what is the user message? User message is explain AI. So you can see explain AI and you got output. And you can see all the information. What the tools called? RRRS web search is called. So RRRS web search is called. Is it having any problem? No problem. All are green. At this, you can see what are the inputs, what are the outputs, what are the attributes used like that. Then before this, before professor, we have used teacher, right? So that means before, this is the teacher, means 3 lines. So if you go here, teacher means give the answer in 3 lines, right? System prompt. Let's see if it is there. Okay, so you can see you are a helpful assistant, give the answer in 3 lines. And you can see which tools are called, what is the input, what is the output, like that. Like this, you can use the LangSmith for monitoring purpose, debugging purpose, observability purpose. Monitoring purpose, debugging purpose, observability purpose. That's about the LangSmith. Okay, observability purpose, evaluation purpose or evaluation platform, debugging purpose, monitoring purpose of your LangChain agent application. Your LangChain agent application. That's about this. That's about this. Now let's go to the nodes and see. So this is the nodes. So far we are able to see the system messages, AI messages, tool messages, but we are not able to the system messages or system prompt. Then how to do that? For that we can use the LangSmith. What is the LangSmith? You can visualize that is like a logging and monitoring if you are a Java person. Okay, so then what LangSmith can do? Okay, what all you can see in the LangSmith. With LangSmith, you can see what the prompt, what the tools, input, output. You can see here. Okay, so what is the prompt, system prompt, user prompt, tools, output, input, attributes. Like this, you can all do it. And you can trace it, error, you can see the errors, latencies, models, all these things you can do. So for that, how do we do that? Go to the LangSmith, first install the package. Okay, then okay, first install the package, then generate the key and put in the environment variables. Then run any existing application. Now we can see the output. That's it. Now people will ask the difference between, there is a LangChain, LangGraph, LangSmith, LangFlow. LangFlow is a design tool. LangSmith, LangFlow, LangFlow is a design. Okay, design AI workflow, design tool in a simple word. LangChain we already do. Build tool, build AI application. LangChain is a build AI application. There is a LangGraph which you will study in the coming. So it's like a orchestration agent workflow. Then LangSmith, just now we see. Okay, observe, debug, evaluate. LangFlow. So it's a design AI workflows. Like that, there is a famous interview question. What is the difference between LangChain versus LangGraph versus LangSmith versus LangFlow? And this is what given here. In a simple word for now, LangChain, build AI application. LangGraph, will study in the coming days, orchestration agent workflow. LangSmith, observe, debug, evaluate. LangFlow, design AI workflows visually. And if you want more explanation, you can see here. That's all for today. If you have any questions, go ahead and ask. Else, we'll catch up in the next session. Thank you.